Thanks, Matthias.
Thank you. Rock on.
Great.
The stage is yours.
Thank you, Matthias. Pleasure to be here in Stockholm. I know quite a few people here in Stockholm. Some of you, I think, know me. For those who don't, jag skulle lika gärna kunna säga god morgon. So Matthias has told me that there are quite a few people attending who don't speak Swedish, so I will actually give the presentation in English. But one of the things I've always been very interested in is, how can I put it, translations and things that mean different things to different people. Sometimes even the same thing can mean multiple things. So here's an example. We have the title of this presentation, which is Make the Future Java Together. And for anyone, how many people went to Java 1 this year? Okay, so not that many. And in some ways that's not surprising, because one of the things that we know, now is although the world is growing smaller and it's easier to travel around, our access to information is actually much better. So we don't necessarily need to destroy the climate by flying halfway across the world in order to go to a conference. And that's in part because we have local conferences like this where you can get much of the same information. So in some sense, the information comes to you. Now, this Make the Future Java, this was the theme for Java 1 this last year. And the nice thing about it is that there are actually a couple of meanings, because this is make the future Java, right? This is about how do we work together in the community to make the future of Java, and Java as it will be in the future. And it is also make the future Java, right? So it's basically, how do we go forward and make it so that the future is one where Java plays very, very well with our needs? Now, before I start, I am from Oracle, so I do have to see if my clicker works. And of course it doesn't. So I have to show you this slide. Now, here, this is a great opportunity for translation, right? Because this slide, as you can see, is not in, well, it's not in Swedish. It's also not in English. It's, if anything, in lawyerese. And I have a friend and colleague, Joe Darcy, who explained to me, he translated it for me once. He said, what this slide means is that this is the only slide in this presentation that is definitely true. Okay, so quick primer here. Some of the speakers who I was talking with earlier, they said, "Wow, we're really excited to be here in Sweden. Can you tell me a little bit? Tell me some Swedish so I can impress people." And I said, "Okay, well, I'll try to. So let's see. Java, and of course, in Swedish, we have Java." All right. Next one here. Yellow jeans, something you say very often in English, is of course in Swedish. Yellow jeans. All right. But some of these are not just things where pronunciation of things are different. So I'll give you an example. In America, something that people go around saying all the time is awesome. And so in Swedish, sådär. All right. So having said that, I do. Here's another thing. This is another kind of interesting kind of cultural translation thing that can happen. Does anyone recognize that? I snapped that photo on my way in. Let me tell you, this is 10 minutes after my flight landed, where I came from FOSDEM at Brussels. And what you don't see is that the baggage hall is completely packed because every single person from the plane is there waiting for their bags. This little yellow line, for those of you who are not from Sweden, is the line behind which you stand in order to wait for all the bags come out. And because when the bags come out, if you're standing behind the line, everyone can see which bags are coming. And you step forward when your bag comes, and you take it, and then you go. And of course, if this were in just about any other country, I can tell you that all of the people on the plane would actually be standing right there in front of me. So you wouldn't be able to see the baggage. So those are kind of interesting ones to note as well. So I don't know what the translation of that is. So here again, JFocus, as Matthias said, this is a tremendous conference. It is a resource that's available to you, and it brings some of the best international speakers in the world here. We saw Charlie Nutter, who just came up. I don't know if you've ever seen him speak. He's absolutely fabulous. He actually described Invoke Dynamic in a way that even I could understand. So, so I think that will be a great one to go to. There are a lot of other great talks as well. And so I'd have to say that, on behalf of Oracle, we're very, very happy to sponsor this conference, and happy to have a lot of people from our ranks who are attending. Now, one thing I will say here is that I have a message from a colleague, Sharat Chander. Let me go back here for a sec. Who asked me to say just a couple of words, and essentially what he said. How can I put it? It may need a little bit of translation. I'm going to tell you so exactly what he said. To Matthias, my personal thanks to you for inviting Oracle to participate in this magnificent spectacle. So just for the Swedes in the audience, Matthias, det var inte illa. Okay, so as you saw in the title, we're here today to talk about making the future Java. But in the words of the immortal poet Bob Marley, you can't get your future, you have to understand your past. So let's see. I wanted to talk a little bit about the past of Java. And this is something, you can go online, you can read everything that happened and, like who did what and, how things were done. But that's not actually what I'm going to speak about. I'm actually going to talk a little bit about this from a personal perspective. So I want to go back a few years and sort of talk a little bit about when I started in the software industry. I came from a little bit of a weird direction, but I actually ended up finding myself in California working for a company called Quintus, who made a programming language. Does anyone know what programming language that was? Prolog, exactly right. And a neat sort of side note here is that there was actually an open source project going that made an implementation of Prolog that used the same APIs, and it was done by 6. So we had Quintus Prolog, and we had Sixtus Prolog. And in fact, 6 actually now runs Prolog and actually owns this implementation that this company worked on. But what was interesting about it was a really neat language with a virtual machine. You could write code that you compiled to an object format that was platform independent. And then you could load it into a virtual machine, and you could do all kinds of stuff. And so that was quite neat. Sounds a little bit familiar there. I ended up working there for a while. The only problem about this was that we were in the US, and actually no one in the US really used Prolog. Well, aside from the government, that's another story. And of course, it was fairly popular in Europe, but it wasn't a language that you could say had exactly widespread use. So in the process of doing that, we started a consulting group with the idea that, well, if we give people a bunch of great examples of this technology being used, then everyone will catch on and they'll start using it, and we'll make the future Prolog. Okay, so that didn't really work out. But one of the nice things was that I got to meet a lot of neat people using the technology, or ways of using the technology, and finding things out about that. And so after about 5 years of working there, I decided it was time for a change. And I had some customers who I had worked with, and some people there went on and started a company. And so they invited me to come and work with them at the exciting World Financial Center. It was actually at the World Trade Center across the street. The World Trade Center, Stockholm. So I worked there at this company, Front Capital Systems. It was doing financial software. And one of the, so actually, step forward, we had been doing Quintus Prolog on Unix, actually a lot of Spark Solaris. It wasn't Solaris at the time, it was Sun OS, X Windows. It was all very future stuff. And the nice thing about that was that, when I went over to my relatives and they said, "Can you fix my PC?" I would say, "I actually know nothing about PCs, If it's Unix, I'll help you." And it wasn't, of course. So anyway, came over here, and this was all of a sudden being thrown into the world of VAX VMS. It was a lot of native programming. And so I got to see a little bit about what that meant. Now, in the course of doing these, one of the things that really struck me was the porting problem. Anyone know what I mean by the porting problem? All right. So what I mean is this. At that time, in the late 80s and in the early 90s, a software development team typically looked like this. You had a bunch of people sitting over here writing the code, and then you had a bunch of people sitting over here, usually about the same number, sometimes even more, porting the code. And they were porting it to everywhere. They were porting it, any platform you wanted to support, you had to port to. And then you always had this dilemma, like, do you try to release everything at the same time, or are ones lagging? And if they're lagging, what comes after, and all that kind of stuff. And it was just a mess. And it was a mess because nobody liked doing that. It was no fun to do. It wasn't, some people did, but for most developers, this was not something that was an exciting task. But it was a huge amount of pain, and it was very, very costly. So basically, when I then got a call from some of the folks that I had worked with at Quintus, who said, "Hey, we've moved over to a new place. We're writing a new language. It's a great core team. People are excited about it. It's just like working at Quintus, except people seem to like the language. And so you should come and help us." And so I moved, at that point, I moved back to California and started working at JavaSoft, where we were trying to change the world by making the future Java. Very small team at this time, and it was a very exciting time. And I think there were people from Quintus. There were also a lot of people from Franz, who, if you're not familiar with that company, they made a fantastic Lisp implementation. And so what was happening was a bunch of people that had worked on kind of similar ideas and similar kinds of technologies were now kind of all in one place and doing this in a new form factor that for some reason seemed to resonate in a way that those others never really had. This was something that was kind of new. It was kind of crazy. It was a very giddy time. In general, it was a time that was giddy for the industry as a whole because lots of people were doing things. There was a feeling that anything was possible. The internet was really starting to bloom, and you saw a lot of people really wanting to get in on the game. But working on the Java team was just an amazing thing. We saw schools starting to take this language and start to teach it. And so a lot of the people who came out of the schools, even at that early time, already knew Java. And that in turn fueled kind of an industry and an interest that ended up building quite a large ecosystem. So for some reason, Java actually made it past this cool little thing that's kind of interesting, but a little quirky, to being something that really was mainstream and was expected. And so I think a very interesting thing to think about is why? Why was that the case? Why did Java become so popular? So these are some of my thoughts on why it might be the case. I'm sure there are a lot more. But in general, my feeling is that Java somehow seemed to hit the sweet spot. It hit the sweet spot in terms of the power that it brought, but also being easily accessible. It was, a small runtime. And in the beginning, there were certainly some performance issues, but what we saw is that over time these got better and better. There also is this very, very rich class library. So it wasn't the case that just because it was small, you didn't have help and support in many of the things that you wanted to do. I also think that Sun did a tremendous job at this early stage of fostering and encouraging ubiquity of the technology. So ubiquity means, of course, that you make it exist all over. And of course, they had a lot of help in that, right? This was not something, even at that early stage, that Sun did by itself. It was an industry that was created by a community of people working together. A lot of companies, a lot of people, all the schools and people who learn Java. And then finally, this porting problem that I mentioned before, really with Java started to disappear. And it's disappeared to the point that when I said, how about the porting problem, I didn't see a chorus of people raising their hands and going, oh yeah, the porting problem, that was awesome. Well, okay, maybe it's because maybe the average age of the audience is too young to remember it. I don't know, but I'll tell you, it's when I look around the industry now and see how people develop software, it's so much more efficient than what it was, and the result is that we all get to work on more fun stuff and solving fun problems. Okay, so why am I showing this? Well, this is sort of, from 2000 on, this is what it was like for Java, right? Sailing to the top of the popularity charts, really, as different shifts happened in the industry from, client and server and then doing more things on the server, from multi-tier architectures to other things, what we saw is that Java's popularity just grew and grew and grew. And it grew to the point where Java was not, first it started out as a fledgling little thing that you could run bouncy heads on, and now it became the thing that was really powering the industry, certainly on the server side. There was, kind of a network effect of this growth. New frameworks became possible. People, if they didn't like EE, they created a new framework, and that became huge. I think there were some other things as well, though. It also, as it was growing, right, as you went from Java version, 1.2 to 1.3 to 1.4 to 1.5, people saw new things happening. They saw new capabilities coming into the platform. And even the existing capabilities got better, and the compatibility story was pretty darn good for a platform like this. And so in general, it was fairly painless for people to move, and moving forward, they got benefit. And another thing that they saw is that as other trends happened in the industry, they were supported. When new hardware came out, it worked. And not only worked, but it worked well. And I can tell you, that behind that story, there actually was a tremendous amount of work on all the people who were implementing Java to make it happen. And I can tell you that in part because around about that point, I had left Sun, and I actually came back here to Stockholm and worked, had the pleasure and the privilege of working with the JRocket team. And so this was technology that was done. It was an implementation of Java that was tuned for server-side workloads. And this was a team that worked very, very closely with Intel and other hardware vendors to make sure that as soon as new hardware comes out of the gate, Java performs awesomely on it. And without your having to do anything, you don't even have to recompile your program. It automatically is tuned to the target architecture. All right, so let's look at this. What we end up with here is essentially saying that, Java is at a position where it isn't just a technology that is giving you a benefit at the start of a project or at the start of a version of Java. It's something that persists and grows in value as things change around you by providing a constant level that's not just constant, it's a constantly rising bar. Okay? So I think that's another reason for the sort of persistent popularity of Java. So I want to talk about this a little. The next thing that happened for Sun was actually open sourcing Java. And this was something that happened for a number of reasons. I'm not going to go into those right now, but I am going to come back and sort of talk about OpenJDK and what this means. So first of all, I want to sort of say like how this happens today, which is that OpenJDK is an open source project, an open source community that you can come to and see Java being developed and take part in that process. It's something that's open to individuals to join. It's open to organizations to join. And now we have quite a great deal of people who are doing just that. Okay, I'm going to come back and say more about OpenJDK in a minute. I'm going to talk about what happened to Java next, which is in the sort of mid to late 2000s. So basically, can everyone see what this is? Okay, this is a plateau. And so essentially what happened was Java got to a point where everything kind of worked, it was stable, there were various things going on, not a whole lot of releases coming on, a feeling that there wasn't a lot of momentum. We had an economic downturn in the world, and Sun certainly as a company was affected by this quite a lot. And so the general perception, I think, from the community was there just wasn't much new stuff happening. It was continuing to work, but it wasn't getting better. And as a result, you saw that in the usage, right? It essentially kind of plateaued out. In part, it's hard not to plateau when you're at the top, right? But this is not a great thing. So let's see. What happened then? It's a long history up to this point. But I think that it is helpful because it helps us understand, why did people start using Java in the first place? How did it become so popular? Why did this popularity continue to grow and grow? And also, what was the state of the Java nation, as it were, when Oracle took over stewardship in 2010? Oh yeah, did I mention that? In 2009, this is what happened. It was announced that Oracle was going to acquire Sun. And of course, what you saw was, immediate doomsday predictions. This is going to be horrible. They're going to destroy it. They're going to turn it, make it into their own proprietary technology. Well, interestingly, even at that time, many of the companies and the individuals who were most closely involved with the implementing of Java were actually not that worried. Because they looked at it and they were like, things were not moving all that great. We saw that the investment that we wanted to see and the forward momentum was not there. And, say what you like about Oracle, but Oracle is very rational and very business-driven. And Oracle has a tremendously large middleware business that is based on Java. And so it would just be crazy for Oracle to try to destroy this in some way by destroying Java. And of course, as we've seen, this is something that has continued with investment. Let's see. So I'm just going to mention here, these are sort of our thoughts on the things that need to be focused on for the future of Java. And this is what we've been working on the past couple of years. I think the other thing that we started to learn as we integrated teams, so for instance, the JRocket team that I worked with from BEA that had come into Oracle, merged together with the Hotspot VM team from Sun. And so this was kind of a learning process. And of course that takes a while. But one of the main important things that we learned was, Java is not something which is just a software project. It's more than that. It's bigger than that. Java is a community. the community aspect of Java is something that's very important to its success and its evolution. And there's a great base of technology, but it was technology that had kind of languished a bit and needed brushing up and shaking off and a good dose of investment. And then finally, this bottom part is about leadership. And what I mean by that is the responsibilities that Oracle takes on as the steward of Java in order to lead it in a way that's responsible. Okay, so a little on community here. There are a couple of aspects I'm going to mention here, a little bit about the JCP and a little bit about OpenJDK. And one of the questions that I get is, well, what are these? What's the difference? I just want to mention very, very briefly, the JCP, the Java community process, this is basically something that's about developing the specifications for Java. And this is something that was actually put in place long before the open sourcing of Java as a way of being able to have people collaborate on the specification. There's going to be a great talk on this by Heather and Martijn. I'm not sure exactly what time it is, but check it out in your program. If you're interested in this topic, I think you'll find this a very, very interesting presentation. Another aspect of community, Java user groups. How many here belong to a Java user group? Okay, it's quite a number. What I would tell you is a Java user group is a local organization that provides all kinds of fabulous resources, information, talks, etc. They exist all over the world. They're growing. And what I'm seeing now is that Java user groups are working very, very closely together. So, as an example, we see programs started by, for instance, the London Java community that are then being adopted by other folks. An example, just looking back to the JCP, is a program called Adopt-a-JSR. And this is something they put together that can be run through a JUG and gets people participating and reviewing and helping to give comments on specifications. All right, now I'm going to talk about OpenJDK, and here, as I mentioned earlier, Java had been open for quite a long time. But one of the things that you saw if you looked at the community was that there were not that many other, at least corporate participants, that had sort of gone in and joined this and endorsed it. And so from the Oracle perspective, we felt that this was something that should happen. And so we worked very hard to get other folks on board. And now, a couple of years later, I'm very happy to say that we've had a number of corporations that have joined, many in sort of the first wave, or the people you would expect, which are sort of big organizations that implement Java. A trend that we've seen more recently is very, very advanced users of Java. As I'll give you an example, Twitter joined because they've done a bunch of work of tuning garbage collection, and they wanted to be able to get that back into the source base so that everyone could benefit from it. And I think there's actually a talk by Attila Szigeti on that topic. So that is also one to watch out for. So in this sort of coming and revitalizing OpenJDK, we really did a few things. We revised and put in place new bylaws. Okay, there actually had been temporary bylaws in place for quite a long time. We put new ones in place, and it was voted on and made them permanent. We got a new governing board, which has a broad representation from the community, both corporations and individuals. We also did a census of the membership, the groups, and the projects that are there. All of that is there and transparent. You can look at it. And then, basically, this is what we ended up with, right? A place where people can go and work on Java SE and the future implementation of it, and also work on related technologies, and have a way of proposing new ideas of things that can be done. Another thing that Oracle did was we actually made this the reference implementation for the Java SE spec. So that is what the reference implementation is. That means in any doubt of whether an implementation is doing what it's supposed to according to the spec, it is that implementation that rules. All right. I'm going to go quickly through these slides. These are a bunch of sort of statistics and things that sort of says, what's going on in the OpenJDK community, and how is it moving forward? Okay? So essentially, what we've seen here is continuing increase in commits, in number of active contributors, in general activity and discussion in the community. Transparency, here, for instance, we revised the terms of use for OpenJDK so that it is possible to actually run the JSR expert group mailing lists on the OpenJDK infrastructure. So there aren't sort of multiple places you need to go to figure out what's going on. The place where the implementation is worked on and the place where the specification is worked on are sort of hand in hand. The JDK Enhancement Process is one which is there, in order for members of OpenJDK to be able to suggest new ideas. So this is very nice, and of course, if you go and look at it, the first two JEPs are ones that are very interesting if you want to learn about it. JEP number 0 is the index of JEPs, and JEP number 1 is the JEP process description. Okay, here's just a little bit of information so you can see some of the corporations that are involved and how that's expanded. Okay, so that was a bunch of slides on how absolutely tremendously wonderful things have gotten in OpenJDK. Swedish translation, jag fattar. Okay, so there are a bunch more things to be improved, and this is something where, everyone is welcome. So please go and look at it. I think a great way to get started is actually to just go and look at some of the mailing lists. You can read the traffic and find out what's going on in particular areas. If you want to do it in a more organized way, there's another one of these great programs that was started by the London Java community called Adopt-a-JSR. And one of the things they've done is put together something that makes it easy for a Java user group to put together a hackathon where you can get people together, learn to build OpenJDK, start to look at particular areas. I think they've done Nashorn and they've done Lambda and a couple of areas, and use that as a way to give feedback to us as the product is being developed. Okay, so now we're going to go on and go from this sort of generalized perspective and talk a little bit more about specific technology. All right. So first of all, I would be remiss if I didn't sort of say Java 7 and how things are going there. This data is a little bit old, but as you can see, there's actually been a very nice and fairly swift adoption curve of Java 7. How many people out there are actively running Java 7 now? All right, good. There's a good number. How many people are still on 6? It looks like about the same number, so maybe these statistics are not representative of Sweden. How about 5? Okay, you're too embarrassed to raise your hands. I know you're out there. It's okay. There are some great resources out there for information about moving up to 7, and it's something I'd encourage you to look at, in part because the end of public updates of 6 is coming very soon. And so what you will find is a lot more usage of Java 7 out there. Here we go. So this is just general list of sort of, things that are there in 7 and reasons why you might want to use it. Going back to what we said before about why Java was popular and why it continued to grow in popularity, you can see that many of those elements are actually represented here in some way. So we see the coin small feature enhancements. That is something that's about responsible evolution of the APIs. In addition, in some cases, a completely new area on NIO 2, something where new power is being brought to you, which you can choose to use or not. There were also a number of performance enhancements and other things. In addition to some initial convergence of the JRocket features, and then also increased standards compliance, as well as some new under-the-cover features like Invoke Dynamic. And that becomes important in just a little bit here. Okay, so even after the GA of 7, as updates were going on, new value was being brought along. So I'll give you an example. How many people here run Macs? Yeah, a whole lot. Very popular development platform. One that where the porting problem had actually been a porting problem for Java, where in the past, the new versions as they came out lagged behind quite a bit on the Mac. As you've seen, Apple came to OpenJDK and donated the base contributed the base of their implementation. It's been taken forward and is now a standard platform. And so if you go back and look at the updates of 7 that you see happening now, they're happening simultaneously on a Mac. And that's something that never happened in the past. In addition, we also, actually, are there people here who are running on Linux on ARM? Yeah, not very many. I'm going to come back in a couple of years, and like everyone's going to raise their hand. That's also a new platform that we support there. Okay, good. So that's kind of state of things where they are. I want to talk now about coming trends, because we said that the value proposition of Java is you've invested in it, and it's going to keep getting better for you, right? As new things come, you're not going to have to worry about stuff as much because you've essentially future-proofed yourself. Okay? So I want to talk about a few of the new trends that are coming in the industry, and in order to do that, I'd actually like to invite a couple of friends and colleagues up. So first off, Arun Gupta.
George.
Hey. Okay, Arun, welcome.
Thank you.
How did the run go yesterday?
Very well. Yeah, there were 4 of us. Actually, 7 of us started. Some kind of lost on the way. They recovered their way back.
Okay.
And 4 of us did pretty good. It was a good 10K run by the river.
Very nice. Okay, good. Well, why don't you tell us a little bit about EE and the cloud and what's going on and what we should look for in the future there?
Sure. Java EE is already very well suited for cloud in the sense, it gives you that container which is isolated by itself. It gives you that automatic discovery of resources. It gives you that portability. It gives you that standard APIs. So that way, Java EE is already very well suited for running in the cloud. Yeah. There is a lot of innovation happening by lots of different vendors, not just Oracle in terms of Oracle Cloud, but Red Hat is doing OpenShift. CloudBees is doing a fantastic work on the ability by which you can take your Java EE application and run it on different cloud vendors. With Java EE 6, simplicity and everything, we really took it to the next level. Java EE 7, which is what is getting scheduled for later this year, we are embracing HTML5, things like WebSockets, JSON processing, batch processing, concurrency, all of those are coming in. So all of these standard APIs will really let you build a very standard application, standard feature set that you need, portability, etc., that you need for deploying and running your application in the cloud environment. This is going to form the basis for Java EE 8, which is going to be the next release, which is where we're going to provide how a standards-based PaaS platform could build. So effectively, a true portability across different cloud vendors. So you can have a Java EE 8 application built, and then you could port it across different vendors.
Okay.
So that's what we're looking at right now.
That sounds great. So if someone's interested in knowing more, where can they go?
Absolutely. So I think there are 2 big pointers that you want to remember. There is a Java EE-spec.java.net, which is where all the specification work is available in terms of what we're doing in Java EE 7. And of course, the corresponding reference implementation is Glassfish. So you go to glassfish.org and download the latest bits and give it a shot.
All right. Sounds good. Thanks, Arun.
Thank you.
All right. So now I want to talk about the next couple of these here. And to do that, I'd like to have my friend and colleague Mark Reinhold come. Mark is the chief architect for the Java platform. And he also has a problem with stairs.
Problems with this platform, yes.
With this platform, okay. Well, thankfully this is not the Java platform. So, Mark, tell me a little bit about what's going on in hardware and multi-core, and what are we doing in Java to help with that?
Sure. So the whole multi-core thing is really interesting. The hardware guys, of course, are they recently, well, not too recently, started running up against the fundamental limits of physics. You can only make a processor go so fast before the power consumption will just cause it to melt down because you can't dissipate the heat enough. So the response to that is rather than making one core go faster and faster and faster, let's just put lots of cores on a chip, because after all, Moore's law does not say that chips get faster and faster. It says that the number of transistors doubles every couple of years. So that's why we have multi-core. The thing is that programming multi-core processors by hand is really tough. Now, Java from the very beginning has had very good support for threads and concurrency and locks and all this other stuff. But I think of that as sort of the assembly language of concurrent programming. You can do that. If you're as smart as Doug Lee, you can do it pretty well. How many people in this room are as smart as Doug Lee? I am not one of them. I remember the first time I wrote a truly concurrent garbage collector running on a multi-core machine at a digital lab in the late 80s. It took me my entire summer internship to get the synchronization right.
It's funny. I asked that question once, and Doug Lee was in the audience. Oh, well.
Anyway, so...
He raised his hand. It's okay.
Anyway, so programming at the assembly language level of multi-core is really tough. What we've been doing in the Java platform and this is a plan that's spanning several releases, is trying to make that better. In Java 7, we introduced the fork join framework written by this really smart guy named Doug Lee. And the fork join framework, for many kinds of concurrent programming problems, does make life a lot easier. But it still requires you to understand the framework, which, it's way smaller than most things that are called frameworks, but it's still, there's a learning curve there. And for some other kinds of problems, it just doesn't fit all that well. So to go even further past that, we want to be able to enhance the built-in collections APIs that we already have, so that you can write code not in terms of threads and locks or in terms of decomposable fork join tasks, but at the very much higher level of saying, okay, well, I've got a collection of things. Let me apply a series of bulk operations to it. Basically filter, map, and reduce. Think of it as Hadoop for Java objects, if you like. So express programs in that way, and have the libraries underneath the covers figure out all the parallelism details itself. In some cases, map onto the fork join framework. In other cases, use a massively concurrent data structure and other kinds of models. So that's where we're going with the libraries. Now, if we could do that without evolving the language, but people know about nested inner classes. You've written a lot of those, and you know how painful it gets if you need to write multiple things in multiple nested classes within the same statement, even sometimes. One of my very favorite quotes from a customer is, "Yes, we have this library that requires our developers to use nested classes a lot, and our eyes roll into the back of our heads with the pain every day." So that difficulty is the primary motivation for doing Lambda expressions, which are coming in Java 8. Brian Getz has been leading that, and he and the people involved have done a fantastic job of figuring out how to bring Java forward, along with all these other languages that finally caught up with Lisp, which of course had it in 1963. So that Java 8 will have Lambda expressions. It also has a very cool feature that finally allows us to evolve interfaces in a compatible fashion called default methods, as well as a few other goodies. So I think both the language expressiveness story and the multi-core story in 8 are going to be really strong. Now, the other thing you wanted me to chat about was polyglot programming. Yeah. And that's another longer-term trend that we've been working on for quite some time now. The beginning of that, of course, was Invoke Dynamic JSR 292 in Java 7. That was the first new bytecode introduced into the Java platform in 16 years. And that bytecode was not designed for Java. It was designed for languages that need to do efficient dynamic dispatch. Things like JavaScript, Ruby, even like Smalltalk might benefit, right? Not sure about Prolog, though.
Somebody told me there's an implementation of Prolog on the JVM. I haven't checked it out yet.
Anyway, so
I think it's going to be big.
Yeah, in a year now. The same year Linux takes over the desktop, I think. Anyway, so Invoke Dynamic was a big innovation. that helped a lot. We got a lot of great feedback from folks like Charlie Nutter, who does JRuby and has given us lots of fantastic feedback on what's wrong with it and some of the things that are good with it. John Rose, who led that work, in fact, recently completed a pretty much brand new re-implementation of it. The original implementation of Invoke Dynamic in the hotspot VM was a little complicated. And he realized while he was desperately trying to finish that up for 7, oh yeah, there's this much cleaner way to think about it, but I don't have time to do it for 7 because it was May and we were shipping in July. So he held on to that idea and pursued it, and that new implementation it's in the Java 8 code base, and will soon be backported into 7 update, whatever the number is.
Yep.
So that's cool. But this is something we're continuing to push on. Supporting languages other than Java on the Java virtual machine is extremely important for the overall vibrance of the platform and the community. Lots of people are in situations where they need to deal with languages other than Java.
So you mentioned these things, and that Invoke Dynamic was kind of originally done without any thought of using it in the Java platform. But that's not the case anymore, is it?
In a wonderful twist of fate, it turns out in Project Lambda, they were considering all the different ways one might implement Lambda expressions on top of the Java virtual machine. And I don't know if it was Brian or Doug or somebody else had the brilliant realization, wait a minute, we can use Invoke Dynamic for this. So it turns out that this bytecode and feature that was initially conceived without any regard to Java language is turning out to be very fundamental to the future of Java language. So that was a nice bit of luck.
Okay, and this Nashorn thing, what exactly is that?
I think it has something to do with red rhinoceroses.
You could be right.
So Nashorn is a brand new implementation of JavaScript, funded primarily by Oracle, although some other folks are starting to get involved now that it's open source. We did this from the ground up, just started complete blank slate. Let's do an ECMAScript compliant implementation that leverages Invoke Dynamic, to push on Invoke Dynamic, push on the VM, push on performance, but also provide a really good JavaScript implementation on top of Java, because lots of developers want to be able to mix JavaScript and Java in various scenarios. And it's been an interesting thing to watch. I haven't worked on it myself, but Jim Lasky and the team have really done a fantastic job. Performance is not, it's I think within shouting distance of V8, like not off by more than a factor of 2 on a lot of benchmarks. On some benchmarks, it's actually better. And the really slick thing is Nashorn is the first JavaScript implementation ever that can pass all of the ECMAScript conformance tests. They achieved that a few months ago, back in the fall.
Crazy.
So it's great. But we did manage to get the code through the whole open sourcing legal process, and that's been a project in OpenJDK since December. And a number of people from other organizations are getting involved, which is great.
Great. And in terms of ways to learn about this, actually quite a bit of the work on Nashorn is going on right here in Stockholm, right over across the water in the development center that we have on Södermalm.
And Oracle's hiring, right?
I heard something about that.
You're the management type.
Well, I want to have respect for Matthias and not make this into a sort of recruiting drive. But yeah, we're hiring. Okay, thank you very much, Mark. Where else, if people are interested, what other things would you recommend for them to learn about Lambda?
Of course,
and Nashorn?
you're here at JFocus, so there are plenty of learning opportunities. I can plug my own talk at 1 o'clock, which is going to be sort of random. My plan for that talk is actually not to spend the entire time on slides, but to go through some stuff. I'll go through some Lambda examples at the beginning, touch on some other things, and then what I'd really love to do is have an open Q&A session. So if you have a question you've been burning to ask, come to the session at 1 o'clock. It's right here in this room.
Okay, that sounds great. Thanks,
Okay.
Mark.
Thanks.
All right, we'll see ya. Got to get him to work on that part. All right. So, okay. So I'm not going to spend a long time on the next one. I'm just going to mention it, and I'm going to mention it in part because Matthias talked about it earlier. And this is, where are things going in this, Internet of Things, M to M. So how many of you today work primarily on things that are going to be delivered in a sort of, desktop and server kind of environment? Okay. How many are mostly focused on delivering things on mobile? Actually, I'm surprised that it's not more. How many people are working on delivering things to embedded devices? There are a few. Okay, good. So I would imagine, so notice who those folks are and go and ask them what their pain is right now. And I can tell you one of the things that you will hear from them is that the embedded world, if you look at it now, looks scarily like the way that the desktop and server world looked in the early to mid-90s. There's a lot of fragmentation. Every vendor is kind of doing their own thing. Most of what you have to do is write in native code, and you have this porting problem, and it's a problem for everyone, because it's a problem for you as a developer trying to target platforms. It's a problem for the vendors as well. And yet at the same time, if you go out and you look at the research, you'll see a lot of disagreement, but you'll see more agreement. The disagreement is about how big it's going to get and how fast, right? Everyone agrees that it's going to. And the reason is kind of simple, right? If you think about it, you look at what is the sort of potential addressable market of desktops? Well, we're kind of there. We're saturated. Just about everyone who has one is going to. How about mobile phones? Well, kind of the same thing. And you know what? It's not more than a few. So I'll tell you a story. We were checking in at the hotel at FOSDEM, Mark and I, and they gave us our code that we could use for the internet. And of course, I don't think anything about it. Oh, no, that's great. And Mark, kind of goes, how many devices can I connect with this? And they were like, you can connect 2. And he was like, could I have a couple more of those? Because he walks around with a lot of devices, but most people don't, right? So even, somebody has a lot, he only actually had 4 with him. But if you think about the number of places that you as an individual could actually have embedded devices, sensors, right? For each person, you could have 50 or 100 of these. Your car already has 50 to 100 of these. And all of those things are little computing units that are becoming more and more capable, right? And just think, if you could actually target all of those different kinds of devices with the same code, the same programming language, possibly the same applications. Of course, think how it would be if there were a rich ecosystem that was providing ones that would help you for particular verticals. Think how it would be if you not only had that for those embedded devices, but a very, very easy way to have trusted information and identity passed from those devices through some kind of intermediate gateway and to a server, which is where all the data goes. And by the way, guess what? On that side, on the server, you're probably already running Java. And so all that knowledge that you have and all of the Java developers out there could actually be addressing this embedded issue as well, which is going to make it go much faster. So that's why I believe that this is going to be absolutely huge. Can everyone see this? Oh, I have to hold it down a little bit. Can you see this? So this is something made by a fellow who is over with my colleague Henrik Stoll giving a talk on embedded in this embedded subconference. This is a Centurion wireless module. So this runs Java. It actually runs Java ME, but a quite capable newer version of it. And I believe it has about 8 gig of ROM, 2 gig of RAM. And it is 3G enabled. And this thing is, you can imagine this being embedded in all kinds of stuff. And in fact, it already is, and I think will continue to be. He was telling me about a kind of cool project. This is just to show you, not only is it things where it's already used, it's also the capability of using it in new situations we haven't even thought of yet. In Brazil, in the rainforest, they're taking these things and they're putting them on, every 100th tree, so that they can detect immediately if there's illegal logging activity going on. That's kind of cool. I'm gonna skip over this, and I'm just gonna mention, as we said here, in general, lots of solid progress, lots of cool things to come. Lots of information about these at this conference. And here basically, these are all areas that are being worked on in the Java community today. This is not only about Oracle. There are ways for you to get involved, both in the specification side and working on the implementation, and in the community and helping one another. So Swedish translation of that is lite hjälp tack. So with that, things you could do: join the Java user group, watch the night hacking tour, listen to the Java Spotlight podcast, go and heckle the JPosse guys, the Java Posse guys, and start to look into embedded, because you know what? I hear it's going to be huge. Thank you very much, and please come and help us make the future Java.